How are you doing? Good morning. So Math 8, I'm excited to continue to work on Unit 9 with you guys, right? We are going on to talking about, we've been talking about dilation, right? We talked about the last three transformations in Unit 8. Now we're in Unit 9. We're going to talk about dilation and similarity. And I think this lesson will really combine the understanding of similarity or even what that is. We talked about dilation so far and how it either grows an image or it shrinks an image, right? We talked about give me a second. Let me cut on one of these lights over here. Just 1 second. Hold on. All right. Yes. So we've been talking about dilation. So I want to talk about similarity a little bit today, but we've been talking about when I gave you a scale factor and you grew or shrunk the image yourself. Now I want you to identify what is that scale factor. Now, scale factor, keep in mind, is the number that's multiplying by the signs or the point to increase or shrink the image, right? I want us to look at a couple examples, and then what I want to do is I want you to complete the Google form I created for you. There's only 2 problems for you to do, which are not bad. One is multiple choice. The other one is actually doing the work, as I'm going to show you how to. And that'll let me know that you watched the video and you also know how to complete it, okay? It's important that you watch the video, also learn how to complete it. That way you complete the assignments I'm giving you. This may be how I'm going to go forward and just create 2 questions on a Google form for you to complete rather than having the full worksheet for you to have to complete. But I want you to do your best, learn, watch the videos, and gain a better understanding of the content. All right, so let's dive in. All right, so I'm going to share my screen with you. Hold on 1 second. There we go. All right, so let me just go back to the beginning so we're all on the same page. All right. So we've talked about so far looking at dilation, something like this, right? Imagine there was triangle ABC and they asked you to dilate 3 scale factors. What would that mean? And that's like the notation D3, which is a dilation of 3 scale factors, which you will multiply each point by 3. So you see how -2, 1 was A, and it became -6, 3, because -2 times 3 is -6. 3 times 1 is 3. And they did it to each point. And all of a sudden, this small triangle became this large triangle. That's dilation in a nutshell, multiplying by the scale factors to get either a bigger image or a smaller image. However, if I were to give you just the images itself and the measurements, could you tell me what the scale factor was? That's what I want us to try to aim on doing. Now, keep in mind, we're going to also about something called similarity. What is similarity? That means that the images are the same or similar, rather. When I say similar, it means that they correspond to each other. So for example, if you look at these 2 triangles, ABC and then A prime, B prime, C prime, you'll see they're both triangles. If we learn a little bit about angles, we'll know all the angles are still the same angle measurements. And there's a correlation between these sides. Imagine this side was measurement of 6 and this side was a measurement of 2. 2 times 3 would give you 6. So you'll be able to understand that I went from one to the other. And that's what I want you to work. I want to show you today as we go into this lesson. So let's dive right in. I'm going to do a number of examples with you. Here goes some just visual examples for you to see. Imagine I have this triangle here where a side was 6, another side was 8, and this hypotenuse was 10. You'll see that the sides, and I want to just notate here as I go through. Cool. You'll see that this side 6, right? This side 6 became 12, right? This side 6 became 12. And then this side 10 became 20. Well, how did I go from 6 to 12? How did I go from 10 to 20? We're not adding here, we're multiplying. So what did I multiply by to go from 6 to 12? What did I multiply by from go from 10 to 20? And if you're thinking about it as I am, you probably gonna think, oh, it's simple. All we did was multiply. And you're absolutely right. What do we multiply by? We multiplied by 2. And that's why it says it has a scale factor of 2, which means that we multiplied each part by 2. Okay, so let's look at another one here. If you look at this triangle here, you have the AB, line AB is 8, line AC is 6, and line BC is 9, right? I go from AC, which is 6, to 12. I go from 8 to 16. I go from 9 to 18. What did they multiply by? Once again, they multiplied by 2. That means the scale factor there has to be 2. Now, it doesn't have to only be triangles. It could be any image itself as long as they are similar and they're growing by the same exact amount when you multiply it. It could be a quadrilateral like this. And you'll notice in this quadrilateral we have AB is 5, and DC is 5, and BC is 4, and AD is 4. But let's just focus on one side for now. AB, which is 5, goes from 5 to 20. Let's look at another side. AD is 4, and that goes from 4 to 16. What are they multiplying by? How do I go from 4 to 16? How do I go from 5 to 20? That's a multiplication of 4. We're thinking about multiplying 5 times 4 gives us 20. 4 times 4 gives you 16. So the scale factor for this particular example would be 4. And these are just some visual ways of doing it. I'm going to show you another way to work on it in a second, and then you need to go and log on to Google Forms to identify the scale factors of those. Let me mention one more thing before I go through my example. Will the scale factor only be going from will it only be whole numbers, right? Will it only be whole numbers or solid numbers? No, it could be fractions, it could be decimals, right? It could be a 0.5, it could be 1.5, 2.5, 6.5. It could be fractions, right? It could be anything. Keep that in mind as we go forward, okay? So let's do it. Let's look at the very first modeling example, okay? The first modeling example that we have here, you'll see it says the images below are similar, right? These images below are similar. And we need to determine the scale factor from this image on the left to that image on the right. Now, there is a little formula here that I want to walk you through. But let me start off by, let's look at A, let's look at B. So if you look at A, we have 9. Stop touching stuff. And it goes to 90. We have 13 and it goes to 130. This right here is kind of like a formula, right? This is really a number multiplied by the scale factor has to equal another number. So if I were to fill this in based on these two images that I see there, it would look something like this, right? It would look something like, hold on, give me a second. Okay. If I were to fill them in, let's say it would be 9, right? 9 here. 9 times S has to equal 90. Oops, sorry. It kind of glitched on me a little bit. Right, so 9 times S equals 90, which means we have to figure out what S is. Now remember, this is also a one-step equation. We've spent time solving equations. We spent time getting to the place where we know how to solve them. And I'm gonna probably revisit it in June because I think that's something essential for you to know in order to go into 9th grade next year, 8th graders. So when I look at 9 times S, I want to say, okay, how do I get rid of the 9? I need to solve for S. My goal is to find out what is S. Now, most of you guys already have the understanding of, okay, 9 times 10 is going to give me 90. But if this was a number that was not as straightforward, I want you to know how to actually calculate it. So, for example, if it said 9 times S is equal to, I don't know, 52.5, right? I would want you to know, okay, how do I do that? I need to divide. Now, why am I dividing? We always want to solve for a letter or a variable by doing the inverse, by doing the opposite, right? We talked about inverse being opposite. This is multiplication. The opposite of multiplication is division. So I'm going to, if this is multiplying by 9, I'm going to divide both sides by 9. Now I'm going to imagine that this little line right here is really a division line on that side. Divide this side by 9. Divide this other side by 9. And we end up getting S is equal to 10. Okay, so the scale factor for this particular example, right? The scale factor for this example would be 10, right? And that's what we just came to the conclusion of, right? Was it hard? No, wasn't hard at all, right? We know that we're looking at similar images, and that's important. If it doesn't tell you that they're similar images, don't try to apply this method, right? Because similar means that every side is being multiplied by the same thing. Right, every side is being multiplied or moved by the same thing. And if it's not similar, then you can't say, okay, there's a congruence here with 9 and 90, 13 and 130, okay? You can set up a proportion if you wanted to as well, right? You could do 90 over 9 is equal to 130 over 13. And then you would still find the actual scale factor, right, which would be 10 is equal to 10. But I would like you to do it the way I did here, right? 9 times something has to equal 90. Or you could have put 13 times something equals 130, divided both sides by that number, and you would have ended up with your scale factor. Let me do one more example with you. I'm going to clear the text. Right? The images below, once again, they're similar. That's the beautiful thing. They're similar. They want me to know the scale factor from this one on the left to the one on the right. Now notice they kind of flip the image. It's moved in a way that they don't look exactly alike, but they are similar, which means that there is some congruency we need to know, right? We need to remember that that means that this side down here, this side where it's 4, is similar to this side over here, which is 52. Okay? Did you have to use those? No, you could have used 7 and 91. Either one of those 7 and 91s, those are both congruent to the opposites as well. I'm going to use the 4. I'm going to use both of them. I'm going to do both of them because I feel it's best to do. Let me do the 4 first. So 4 times S, right? So 4 times something would equal 52. So what times 4 is going to give me 52? Now remember, this is multiplication. The opposite of multiplication is division. So the opposite of multiplication is division. So I'm going to, and you can put a little multiplication mark there if you want. Divide both of these by 4. And you end up getting the scale factor according to this. Oh, sorry. That was not right. Okay. So you end up getting the scale factor S is equal to 13. Okay. Now, will they both give me the same scale factor? They should. Let me try another one. Let's do 7 times S, right? Maybe you did the 7 times S is equal to 91. Okay. Because it's multiplication, once again, we got to do the opposite, which is division. And if you do 91 divided by 7, once again, you get 13. Okay, you get S equal to 13. That tells me the scale factor is 13. So this is how we find a scale factor of similar images, okay? That's how we find the scale factor of similar images, all right? So, all right, what I want you to do is this. After you've watched this video, please go on to do the actual Google form. If you have any questions, just put the questions inside the actual comment section underneath this video. Not necessarily on YouTube, but on the actual Google Classroom portal. That way I can be able to access your questions as well as answer them, all right? Thank you all for watching it. Please work very hard. We're gonna work on doing different dilations that come up this week. I'm looking forward to it. I hope you are as well. All right. Thank you guys so much for tuning in. I will talk to you later.